Okay, now we'll take a look at a couple of examples for linear combination. So if you notice right off the bat in part A, we don't have a single coefficient that's 1, and so that's why we're going to take a look at using linear combination in this method. So now I need to look at the individual x's and individual y's and see if there's any way that I could create an opposite coefficient. And so with 2 and -3, I would actually have to multiply something to both parts to create an opposite coefficient. So before I take that route, what I'm really going to want to do is see if I could do it with the y's. And I notice that I have a -6y, and I would simply just need to multiply 3 times 2 to offset that -6. And so what I need to do is I need to multiply the entire second equation times -3. So I'm going to actually multiply this whole thing times 3. Now, I'm just going to simply rewrite the first equation. So that's 2x minus 6y equals 19. And my new equation, my new second equation, will be a result of me multiplying 3 times everything. So that's going to give me -9x plus 6y equals to 30. And notice I've taken particular care to keep the x's stacked, the y's stacked, and the equals and the answer stacked. And so now I'm going to combine like terms. So 2 and -9 is going to give me -7x. The -6 and the +6y are actually going to cancel each other out. And then I'm going to have 19 and 30, which is going to give me 49. And so if I simply divided both sides by -7, I would get x equals to a -7. Now, I need to take that -7 and substitute that value in for x in either one of the original equations. And so it really doesn't matter which equation you pick in this substitution process. So I'm going to choose the first one. I'm going to say 2 times x, and of course I'm going to replace that x, minus 6y equals 19, and of course in place of x I'm going to put this -7 value. And now I will solve this down for y. Okay, now you can see that y equals to a -11/2. And so I need to write this as an ordered pair. So that's -7 for my x and -11/2 for my y. I personally prefer you keep it as an improper fraction. You will need to find out what format your teacher wants the fractions in, either mixed numbers or decimals, but I personally prefer improper fractions. And so you can see our ordered pair that is the solution to this system of equation. It's not a real pretty ordered pair, but it's the correct answer. So let's take a look at part B. Again, part B, I need to identify a place where I can create negative or opposite coefficients. And so right off the bat, if I just multiply 2x times 2, I can get an opposite coefficient. So I'm going to multiply this entire first equation by 2, which is going to give me 4x minus 6y equals to 2. And then of course I'm going to rewrite the first equation, or the second equation, exactly the way it is. And when I do that, the 4x and the -4x cancel each other out. -6y and +2y gives me -4y, and then 2 and 6 gives me 8. Y is going to equal to -2. Again, I simply need to substitute that -2 for any of the y's, so I'm just going to rewrite one of these equations, and it does not matter which one, and I'm going to replace that y with -2. And now I'll simply solve for the x. And now I have a value for x, and I have a value for y, so the solution to my systems of equation will be the ordered pair -5/2 and -2. Okay, and that was 2 examples of linear combination, or what is sometimes referred to as the elimination process.